What's up? It's Ryan. Today we're going to be working with ellipses. And ellipses are super important and they're cool. And hopefully by the end of this video we can get a little bit more comfortable with the formulas and equations involved with ellipses. So ellipses are essentially stretched out circles, and they can be stretched out horizontally or vertically. And so some components of an ellipse is the major axis, which is pretty much what it sounds like. The axis that's the longer axis, so this would be considered the major axis, and this short axis is considered the minor axis. And at the end of each of these axes, we have vertices. So we call these vertices at the end of the major axis vertices, while these ones are considered co-vertices. And we also have two foci, and those are these points right here. And essentially, these points are going to be important in an equation we talk about later, c squared equals a squared minus b squared. But these foci have some interesting facts about them. For example, if we pick any point along this ellipse, the distance from one of the foci to that point and the distance from the other foci to that point, d1 and d2 respectively, the sum of those distances will be constant no matter what point you choose. So for example, when we add these two distances up, they will be the same as up here, and that's true for any single point. They're also cool in the sense that if we emit a ray from this foci and have it hit this point, it's going to sort of go through this point too. And so those are some cool facts, but we're mainly going to be using these foci for this equation down here. Okay, so let's talk a little bit about the basic formula for an ellipse in standard form. So this is for when a is greater than b, and so a is basically going to relate to our major axis, and our major axis is going to have a length of 2a, and b is going to relate to our minor axis, which is going to have a length of 2b, right? And essentially the vertices and co-vertices of this ellipse, we're not horizontally shifting this, right? If we think about it like a circle, we're not adding or subtracting anything from x and then squaring that. So our center is going to be at the origin, and so that's how we get these vertices and co-vertices. And this will make a little bit more sense when we apply it in problems later in this video. And then the foci are the same, right? We have a center of 0, 0, and so our foci are going to be along our major axis. And so in this example, right, A is relating to our major axis, and so we're going to be dividing x squared by a squared. And so since a is our major axis, we're going to be horizontally stretching that circle into an ellipse. Sort of, you can think of it as our major axis is always going to be longer than our minor axis, of course. And then since our a value is under our x value, we're going to be horizontally longer than we are going to be vertically, if that makes sense. So we also have this equation, c squared equals a squared minus b squared, and essentially what that means is our c value is going to be this length, and then our a value will be this length, and our b value will be this length. And so when we take our a value and square that, and our b value and square that, and we subtract those two, we'll get our c value. And so essentially, if we know our minor axis and our major axis, we can find out our coordinates of the foci. And we'll work with that a little bit more later. Okay. So it's pretty much the same thing for this side. This, we're just flipping b and a. So now our a value is under our y squared. And so that means we're going to be vertically longer than we are horizontally. And that's how we get something that looks like this. But essentially all the other rules are the same. Okay, graphing ellipses. So let's start with this one. Here, first what I would do is look which is larger, 64 or 25. 64. So I know it's going to be longer horizontally, so it's going to look something like this, right? And now what I would do is in our formula, right, we divide by a squared. So 64 equals a squared. So a is obviously going to equal 8, right? Here, 25 equals b squared. So b is going to equal 5. And so now what I would do, we don't have any horizontal or vertical shifts, which we'll go over in this next problem. So our center is going to be at 0, 0, 0, 0. And our vertices and co-vertices and foci, we'll do that. But what I like doing first is actually graphing this. So we're going to go 8 points, or 8 units in our x and y, or in our x direction, both positive and negative. So 1, 2, 3, 4, 5, 6, 7, 8. I think that's 8. And then should be over here. 4, yep. And then we're going to go 5 units up and down. 3, 5, 3, 5. And now I just like to connect all of these. And I'm not the best at drawing ellipses or any sort of graph like this. It's alright. So what are our vertices? Our vertices are going to be along the major axis, which in this case is going horizontally. So it's saying what is this point, what is this point? That's going to be 8, 0. And it's also going to be negative 8, 0. Our co-vertices are going to be going up and down along our minor axis. So that's going to be 0, 5, and 0, negative 5. Now, what is our foci? So our foci is c squared equals a squared minus b squared. So c squared is going to be a squared, which we found out a was 8, minus b squared, and we found out b was 5. So this is going to be equal to 64 minus 25, which is going to be equal to, I'd rather just do it here, 39. So c is going to equal the square root of 39 if we take the square root of both sides. And so our foci, and here we can't simplify that. So our foci is going to be along our major axis, right? And we're going to go and say root 39, 0, as well as negative root 39, 0. And so that should be somewhere around 6, a little bit more than 6. Maybe here. Maybe those points. sorry, something like that. Okay. If we move down to this problem, now we have x minus 5 squared over 9 plus y plus 2 squared over 36 equals 1. And one thing we'll notice also is all of our equations for an ellipse are going to be equal to 1. And so that's something, when we're given an equation for an ellipse in a different form that's not in standard form, we want it to revert back so it always equals 1. Okay, so this is very similar to circles in this sense when we're horizontally and vertically shifting. So whenever we see something like x minus 5, that means our center is actually going to be positive 5. So we're moving to the right 5, even though it's saying minus. And so it's the opposite. And we see that too with circles, right? And so when we see y plus 2 squared, that's going to mean we're moving left. And so we're going to be at negative 2 in our y direction. So from here, what I would do is I'd graph that. I'd say 5, negative 2. And then here, I'd say which is bigger, 36 or 9? Obviously 36. So a squared is going to equal 36. So that means a is going to equal 6. And b squared equals 9. So b equals 3. So from here, I would just move in those directions. Since our major axis, our bigger number, is under our y, that's going to be where our major axis is. So we're going to move 6 up. I think it should be there. I may have miscounted. No, that should be right. And then 3 horizontally. Something like that. That's good enough. So our vertices are along our major axis. So essentially what we're doing is we're moving up 6. So we can look at it on our graph and say it's something like 5, 4. Or we could also just add or subtract 6 from our y value at our center. And that way we get 5, negative 8. And this way, we're keeping our y value constant, and we're adding and subtracting 3 from 5, so we get 2, 4, as well as 8, 4. And our foci are going to be along our major axis. We do that by doing c squared equals a squared minus b squared. So c squared equals 6 squared minus 3 squared, which is just going to equal 36 minus 9, which is going to equal about 27. And so if c squared equals 27, c is going to equal root 27. And we can simplify that by saying that's 3 root 3. So from here, we're going to be adding and subtracting our c value to our y value since it's going to be along this major axis. So we're going to get 5, and then negative 2 plus 3 root 3. We're also going to get 5, negative 2 minus 3 root 3. Okay. So this next problem should be something similar. Remember to horizontally shift it, and then just remember our equations. It should be relatively simple, but we're going to skip that one for today. So here we're just going to do the odds, but this one I'd encourage you to solve this on your own. Just remember that we want our equations for ellipses to be equal to 1, and that should help you. Okay, so for number 5, we're going to have to do something similar to what we did with circles, and that's horizontally shifting. So I'm going to rewrite this equation, or sorry, not horizontally shifting. I meant completing the square. Sorry about that. So we're going to have 4x squared plus 24x plus something, and I'm going to leave it blank, plus y squared equals 28. And so what I want to do is I want to make something here. I'm actually going to write it out here at first. Make this into a perfect square. And so that's to say something like x plus b over 2 squared. So that's essentially going to be our factored form for a perfect square when our a value is 1. So here what I'm going to do is I need to make my a value 1. And so what I'm going to do is I'm going to factor out of 4 out of these two. So I'm going to say 4 out here. And when we factor out of 4 out of 24, we get 6. So we have x squared plus 6 plus something, and all that times 4. And so here we see that this is our factored form for a perfect square. And when we FOIL this out, we're going to get b over 2 squared as our c value. And if you have any questions about this, I'd go back and watch the circle video because we talk about this a little bit more in depth. But this is the same process. So b over 2 is going to be 6 over 2, which is 3, and that squared is going to be 9. But one very easy place to get tripped up is to add 9 to both sides, right? Because whatever we do to one side, we have to do to the other. But remember that we're still multiplying by this 4, so we need to add 36 to both sides. So I'm going to add 36 over here. And so when we add 28 and 36, we should get 64. And I'm going to factor this into something that looks like x plus b over 2 squared. So I'm going to put 4 on the outside. I'm going to have x plus b over 2, 6 over 2, which is 3 squared plus y squared equals 64. And now what I'm going to do is I'm going to divide both sides by 64. What I get is 4 over 64 is going to be 1 over 16, so we're going to have x plus 3 squared over 16 plus y squared over 64 equals 1. And I know it's kind of hard to see, but that's going to be our answer. So I'm going to skip 6. It should be the same process, but we'll do 7 together, and 6 and 7 should be pretty similar. Okay, so I'm going to do the exact same thing. I'm going to rewrite this so that I can get in a form where I can easily see how to make perfect squares out of this equation. So I'm going to write 25 x squared plus 150x, so I'm moving that over to the other side, plus something, plus 4y squared minus 16y plus something. Sorry, we're not going to put a plus sign there. We're going to put an equal sign. And we should get 159. So here I'm going to start factoring out so that our a value is equal to 1. So I'm going to factor out 25 out of this part. So we'll get 25. This was originally 150. 150 divided by 25 is 6. And we'll end our parentheses there. And we had this exact same thing before. It's b over 2 squared. 6 over 2 is 3. 3 squared is 9. So we're going to put 9 right there. Here we're going to factor out 4 from this part. And don't worry, I haven't forgotten balancing this. 4, when we factor out 4 out of 16, we're just going to get 4. And so when we try to create a perfect square out of this, we have b over 2 squared. So negative 4 over 2 is negative 2. Negative 2 squared is 4. We get something that looks like that. So here we've added 25 times 9, right? Remember that 25. 25 times 9 is going to be 225. And 4 times 4 is 16. So if we've added that to this side, that means we have to add it to this side too. So we've added 225 and 16. And no, we'll do that later. So once we make this a perfect square, we still have 25 on the outside, and this is going to simplify to x plus b over 2 squared. So x plus 6 over 2, which is 3 squared, plus 4 times y plus b over 2 squared. B over 2 is negative 4 over 2, so y minus 2 squared equals 159 plus 225, right, plus 16. That's going to give us 400. So now we divide both sides by 400. And what we end up getting, 25 divided by 400 is going to give us 1 over 16. So we do x plus 3 squared over 16 plus y minus 2 squared over 100, right? Because 4 divided by 400 is 100. That's going to be equal to 1. That's going to be our equation. And here, it might be helpful to just think about it geographically, or graphically, not geographically, sorry, wrong class. Since we have a larger number under this y portion of our equation, this is going to be vertically stretched, so it's going to be vertically longer than it is horizontally. So now we're going to sort of do the reverse. We're given the graph and we need to find the equation. So it's pretty simple finding the center. They give it to us. So this is going to be negative 1, 2. Negative 1, 2. Our vertices are going to be along our major axis, which is our longer axis. So it's going horizontally. And here we see it's, I assume, negative 10. No, it's negative 8. So it's going to be negative 8, 2. The other one is going to be 6, 2. Our co-vertices are going to be going up and down. Here seems to be -1, 5. And -1, -1. Our foci, we can determine by doing c squared equals a squared minus b squared. So this length is going to be equal to our a value. And that, if we count that out, it should be 7. So I'm going to write this off to the side. A equals 7. Our b value is going to be 3. It's going to be this length. So if we do c squared equals 7 squared, which is 49, minus 3 squared, which is 9, we should get c equals 40. And when we take the square root of both sides, we get c equals root 40, which is the same thing as 2 root 10. And so our foci are going to be going horizontally, so we're going to have to add it to our center x value. So that's going to be -1 plus 2 root 10, 2. The other one is going to be -1 minus 2 root 10, 2. I'm going to erase some of this. Well, at least just put c here. Okay. Our equation in this next one. Oh, we forgot to do our equation up here. I'm going to make the font a little bit smaller. So here we have a center that's not the origin, so we're going to have to horizontally and vertically shift. If our center is at -1, we're going to have to do the opposite. We're going to have to add 1. Square that. And we see that our major axis is going horizontally, so our a value is going under our x part. So that's a squared. A squared is 49, so we put 49 down here. Here, we're going to do y. Y, we're moving 2 to the right. Or sorry, 2 up, my bad. And so that means we're going to have to subtract 2. That's going to be over our b value, so that's going to be b squared, which is 9, and that's equal to 1. Sorry, all of this is sort of like messy, a little bit messy. Okay. Down here, our major axis is going to be going vertically, and so that means our a value is going to be under our y portion of the equation, right? Because our a value is related to our major axis. Our center, first order of business, is going to be 3, -2. Our vertices are going to be along this major axis, so they're going to be 3, 3, and 3, -7. Yep. Our co-vertices are going to be 1, -2, and 5, -2. Foci, we've gotten used to this now. C squared equals a squared. Our a value is going to be this length. which I believe is 5. So 5 squared is 25, minus our b squared. B is going to be equal to 2 in this case, so 2 squared is 4. C squared equals 21, so C equals root 21. So that means our foci, since they're along our major axis, we're going to be adding them to our y value for our center, adding and subtracting. So I'm going to say 3, negative 2, plus root 21. And here I'm going to say 3, negative 2, minus root 21. Our equation is going to be x minus 3, right? It's the opposite, since we have positive 3 down here. So x minus 3 squared over, since our x is our horizontal axis, is going to be our minor axis. That's going to be over b squared, and our b value we said was 2. Our b squared value is going to be 4. And y we're going to be adding 2, since we have minus 2 down here. We're going to put that over our a squared value. That's going to be 5 squared. We're going to get 25. That's all equal to 1. And so that's going to be very similar in this last problem, number 3. So here we're going to do a couple of problems just applying all of this. And so we're going to be given a couple of characteristics and use our formulas and equations and general knowledge of ellipses to determine the actual equation. Okay, so our vertices are 5, negative 2, and negative 19, negative 2. So first thing I realize is we have the same y value, but we have different x values. And so what that tells me is if we have, oh god, this is not going to be a great graph, but it's just a sketch. We have, say this is negative 19, and this is 5. Since this is, basically what these 2 points are going to tell us, since these are our vertices, not our co-vertices, our ellipse is going to be stretched horizontally. So our major axis is going to run horizontally, and our minor axis is going to run vertically. So essentially what we want to be able to do is find this length, right? And so one thing we might want to do is just use the midpoint formula, which is x1 plus x2 over 2 and y1 plus y2 over 2. And so that's finding the midpoint of our x values and our y values. We have a y value of negative 2 and negative 2. The midpoint of that's just going to be negative 2. They're the same thing. Here we're going to do 5 plus negative 19. Sorry, that looks like a 4 a little bit. Negative 19 over 2. That's going to give us negative 14 over 2, which is just negative 7, right? So our midpoint is negative 7. So our center is going to be, let's just say something like this. Basically, this distance is going to be our a value. And so that distance, right, we're going from negative 7, negative 2 to negative 19, negative 2. You could go the other way too. It's going to be the same thing. We're going to get 12, right? This is 12. So we get A is equal to 12. And B, right, our entire minor axis, if we draw, let's draw this. If we draw something This is a rough sketch, so I don't really know. Our entire minor axis, ooh, that was horrible. Our entire minor axis, that's so horrible, but it's alright, you get the idea. It's gonna be that length. So our b value is just going to be this portion. It's only gonna be that much. So we have to divide 10 by 2, and we get 5, so b equals 5. Now we're just going to plug it into our normal standard form equation, which, if we scroll up here, sorry, so out of control, it's just going to be something that looks like this. So, since we're stretching horizontally, we want our a value to be under our x portion of the equation. So we're going to have x minus -7, so x plus 7 squared over a squared, which is 144. And then y minus -2, which is the same thing as saying plus 2, squared over our b portion, b squared. That's going to be 25. And that's all going to be equal to 1. Here for number 5, our vertices are 12, -9, and -6, -9. Here, right, we have the same y value for our vertices. So that's saying, right, if we do pretty much the same thing, we have 12, this is just a rough sketch, something that looks like this. That means we're going to get something that's horizontally stretched, something like that. So we want to find the midpoint between these two, and we're just going to do x1 plus x2 over 2. And we could do the y portion, but the y portion stays the same, so we know what the midpoint between -9 and -9 is. For here, we're going to do 12 plus -6 over 2. We get -6 over 2. Or sorry, we get 6 over 2, which is just 3. And so this is going to be our center, right, in between our vertices. So if I actually draw a variation of the thing I drew before, we're going to get something that's our center. So this is our center. And now what we'd want to do is we'd want to find this length, because, right, that's going to be our a value. And when we subtract, when we find the difference between 3 and 12, for example, that's just going to be 9. If we go in the opposite direction, it's going to be 9 too. Now what we'd want to do is we'd want to find the difference between the distance between 3, -9 and 3, -7, or 3, -11. And that's relatively simple, right? That's just 2 up and 2 down. It's going to look something like that. We can draw our ellipse. Gets kind of messy. But essentially, we end up finding this length, which, as I said before, this is our b value. Sorry, this is super messy, but that's just going to be 2. And so we got a equals 9, b equals 2. So this is stretched horizontally, right? Our major axis is running horizontally, so we're going to have our x portion over our a value, x minus 3 squared, right, over a squared, 9 squared, which is 81, plus y minus negative 9, y plus 9 squared over b squared, so 2 squared, which is 4. That's our equation. Down here, first what I would do is I'd find the midpoint between our vertices, which, if we're comfortable, right, our x value is 5 for both points, so we're just going to keep it as 5. And the midpoint between 11 and 15, I'm just going to do it in my head. I'm going to add 11 plus negative 15. We get negative 4 divided by 2 is negative 2, right? We're just using that midpoint formula. And so now this is our center. And so our distance from this point to that point is going to be about 13, right? 13. If we just subtract those two, those two y values, we're going to get 13. And why we're allowed to subtract those two is because we have the same x value. As long as it's along a horizontal line or a vertical line, you can just subtract. Otherwise, you'd want to use the distance formula, which we went over in a previous video. So our a value, right, since we're talking about vertices, we're talking about a major axis, our a value is going to be 13. Right here, we're talking about our foci now, this second piece of information, and that's also going to be along our major axis. But here we're talking about C. So what's the distance from 5, negative 2 to 5, negative 14? That's just going to be 12. So our C value is 12. So now I'm just going to plug it into this equation up here. We're going to get 144 C squared, 12 squared is 144, equals 13 squared, which is 169, minus B squared. And so I'm going to subtract 169 from both sides, and I'm going to get negative 25 equals negative B squared, but I'm just going to multiply by negatives on both sides. We end up getting B is equal to 5. And so from here, we can just write our equation. X minus 5 squared over. Now here's where we have the same x value for both of our vertices, 5, right? And our vertices are negative 15 and 11, something like that. Basically, when we visualize this, since we have the same x value, this line is going to be our major axis. So we're going to be, that's horrible, but we're going to be, it's going to be a vertically stretched ellipse, right? Vertically stretched. So that means our a value is going to go under our y term, right? So this is going to be over b squared. Our x term is going to be over b squared. So that's 5 squared, which is 25. Here to y minus negative 2, so y plus 2 squared over 169, and that's equal to 1. Here, now we're given our covertices and our foci. I would find our center from this. We have the same y value for our covertices, and so that means our y value is just going to be 6. And the midpoint between 0 and negative 6 is just going to be negative 3, right? It's just going to be negative 3. And so now that we have our center, we can find our b value from our co-vertices. And so if we just visualize this on a graph, we have our two y values, which are 6 and something like that. But this is our minor axis, so it's actually going to go longer up and down, something like that. And basically this length is going to be our minor axis, and that's going to be equal to a distance of 6. And our minor axis is equal to 2b. So basically b is going to be equal to 3. We just divide 6 by 2. And our foci are going to be along our major axis, which is going up and down this way. And we see that's equal to 6 plus or minus 2 root 10. And so essentially what we can do from there is we can say this point is -3, 6, right? This is our center. So we're going up 2 root 10, and down 2 root 10. And that means our c value is going to be just 2 root 10, since we're going up and down in both of those directions, that length. So 2 root 10, now we just plug this into c squared equals a squared minus b squared. 2 root 10 squared, 2 root 10, just real quick, 2 is the same thing as root 4, right? So I can say 2 root 10 is equal to 4 root 10, or sorry, root 4 times root 10, which is the same thing as saying it's equal to 40, and that's all equal to c. So c squared is going to be equal to 40. A squared is, we don't have a squared, that's what we're going to try to find, minus b squared, 3 squared, which is 9. So that means a squared is going to be equal to 49, which is a is equal to 7. And right, I said this ellipse was going to be vertically stretched, and so that means our a value is going to go under our y term. A is equal to 7. So x minus -3 squared over b squared, since it's vertically stretched, so over 9, plus y minus 6 squared over a squared, 7 squared, which is 49, and that's equal to 1. Okay, our length of our minor axis is 8. That's going to be equal to 2b, right? Our minor axis is always equal to 2b, so b is going to be equal to 4. Got that easy. Our foci are 11, 0, and 5, 0. So if we graph this out, you know I like visualizing things. That sounds weird. Basically, oops, that's my bad. 11, 0 is gonna be, let's just say right here. 5, 0 is gonna be right here. And so that, the midpoint between that, since we have the same y value, which is 0, you can just put that in, 0. But the midpoint between 11 and 5, right, they have a difference of 6, which we cut in half, 3, add that on to 5, so we get 8. So this is going to be our center, which is that point. And right, our foci are always going to be along our major axis, which obviously in this case it's running horizontally. So that means our a value is going to be under our x term. So our C value is just going to be this length from 8, 0 to 11, 0, or 8, 0 to 5, 0, which obviously is just going to be 3. So C equals 3. So that means C squared equals A squared minus B squared. C squared is 9. A squared we're trying to find out, and B squared is equal to 16. So we move that 16 over, we get A squared is equal to 25. A is equal to 5. Now we do x minus A squared over, I talked before about why A squared is going to be under our x term. So over A squared, which is 25, plus y minus 0. So actually I'm just going to say y squared over B squared, which is just 16. That's going to be equal to 1. Okay, if you have any questions on how I did this or any other questions you'd like me to solve, feel free to reach out. Definitely go to your teacher, go to Mr. Whitaker, go to the tutoring center. Definitely use the internet and also me as a resource. I'm happy to help. Yeah, thank you.